everyone. I am Dr. Jagadha, Associate Professor in the Department of Mathematics. The topic for discussion is solenoidal and irrotational vectors. Here, first we are going to discuss about definition of divergence of your vector. That is, f vector f, the line represents, that is vector f vector. So the vector f is continuous and differentiable vector point function. Continuous, the definition of continuous is limit x tends to a, f of x equal to f of a. That is, then we can say at the point a, it is continuous. Differentiable, then the same if we want at the point a, it is differentiable. Then limit x tends to a plus f of x minus f of a divided by x minus a. That is, x is greater than a, it represents. Similarly, if x tends to a minus, the formula it is as it is, f of x minus f of a divided by x minus a. Here x is less than a, these both are equal, then we can tell that is f of x is differentiable at the point a. Vector point function, that is, if to each point p of x, y, z, 3 dimension, we associate some vector f bar to this, then f bar of x, y, z, it's nothing but vector point function. So now I, j, k, they are mutually perpendicular unit vectors. Unit vectors, their magnitude is 1. If it is vector, it has magnitude as well as direction. Now I dot, here this is the dot product. The dot represents partial differentiation we are going to do. That is, f, the vector f with respect to x, with respect to y, and with respect to z, we will do partially. And with the dot product of these mutually perpendicular unit vectors, I, j, k, is called the divergence of vector f. This can be written in a short form, that is, divergence of vector f, it's nothing but div vector f. Now, this div vector f, it's nothing but I dot dou f by dou x plus j dot dou f by dou y and k dot dou f by dou z, where f is the vector point function. Now, this can be written in another way, that is, we are taking this f bar, vector f out and the dot product also out. These both are same. That is, I dou by dou x plus j dou by dou y plus k dou by dou z of dot product vector f. So divergent f equal to, it is a gradient. That is gradient, it's nothing but I dou by dou x plus j dou by dou y plus k dou by dou z it's nothing but the gradient. In symbol, it is denoted this grade dot vector f. Now, this is a scalar point function. After getting this dot product, the result will be scalar point function. That is, if to each point p of x comma y comma z we associate a unique real number, say example pi, to this, then pi of x comma y comma z, it's nothing but scalar point function. Now, we will concentrate a problem for this divergence of your vector. If vector f is xy square I plus 2x square yzj minus 3yz square k, find divergent f at the point 1 comma minus 1 comma 1. The solution is, now let what is given, the f components are f1, f2, f3 along with the mutually perpendicular unit vectors. So now, so vector f, it's nothing but f1i plus f2j plus f3k. Then divergent f is written as dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Given what is given in the question, given the vector f is written here, the question we have written it here. We want it dou f1 by dou x, we want it. For that, dou by dou x, it is written in the particular f1 place. We are doing the comparison of our vector f with our given question vector f. So f1 is playing the role xy square, f2 is playing the role 2x square yz, and f3 is playing the role minus 3yz square. So thus f1, f2, f3, they are substituted in this formula. After substituting, we got dou by dou x of xy square plus dou by dou y of 2x square yz plus dou by dou z of minus 3yz square. We are doing the partial differentiation with respect to x. Now the variables x, y, z, it is in 3 dimensions. The 3 variables are playing the role. Now we want to do the differentiation with respect to x. Then the x differentiation is 1, but y square, the another variable which is treated as constant. So y square into 1 is y square. This partial differentiation we completed. Now we will move towards partially with respect to y. Here y differentiation is 1, other x and z, they are treated as constant. So we are getting 2x square z into 1, 2x square z. So finally the third term with respect to partially z, we have to do it. So z square differentiation is 2z. So here already minus 3y is there. So it is becoming minus 6yz. So y square plus 2x squared z minus 6yz, we got it. So the divergent f The question it is given at this particular point we have to find. So here x is playing the role, y is playing the role, here z is playing the role. So the x is going to take the value 1, y minus 1, z is 1. We are going to substitute in this particular place. So now here substituting 1 square, here substituting 2 into here 1, 1 minus 6, y is minus 1. We have to be careful. So 1 plus 2 plus 6 we are getting. That's what it is written. The result is 9. Now the second problem, find divergent f when vector f is given gradient of x cube plus y cube plus z cube minus 3xyz. The solution we will concentrate now. So the focusing on the solution, the term we are assuming as some pi. Why we have to do it? That we will discuss later. First, we are assuming pi, that is x cube plus y cube plus z cube minus 3xyz is assumed as pi. We are finding dou pi by dou x. That is, this pi we are going to do partially with respect to x. So x cube is becoming the partial differentiation 3x square. This is neglected and this is also neglected. But whereas here the variables are under operation of multiplication. So that's the reason here x, the differentiation is 1. The y, z, they are treated as constant. It is written minus 3yz. Now, dou pi by dou x we did. We got this is the result. Similarly, the pi we will do partially with respect to y. So the partially with respect to y, this is, we will neglect it as we are going to concentrate on partial differentiation of y. So the y cube, the differentiation is 3y square. And z cube, we will neglect it. Here it is minus 3xyz. So now the y differentiation is 1. The leftover x and z, they are treated as constant. So minus 3xz. Now we focus on partial differentiation with respect to z. X cube and y cube we are neglecting as the partial differentiation with respect to z. So this z cube, it has become 3z square. Here the z differentiation is 1 and 1 into minus 3xy, it has become minus 3xy. The question will be, here x and y we are taking into consideration. Why these x and y they are not taken? The reason is this xy, it is under multiplication with what we are going to do. That is, here we are going to do z partially differentiation. Towards that, these other variables are associated. That is the reason they are treated as constant. Now, grade pi we wanted. Grade pi, the gradient, the formula is I dou by dou x plus j dou by dou y plus k dou by dou z of pi. Next, we are taking the pi inside, so it is becoming here I dou pi by dou x, the first term, j into dou pi by dou y, the second term, the next one is here k should come, k bar dou pi by dou z. What we have got it just now, the dou pi by dou x, we got it, that is substituted here, and dou pi by y, the particular places dou pi by dou y and dou pi by dou z, they are substituted. So now here just we put it in order, that is this is written as it is and here it is written, and this it is written and j is written here and here k should come, here k y. So now the question is divergent, they told, but we are doing the grade. What is the reason? Now we know the divergent of a vector, the formula is vector f, it's nothing but f1i plus f2j plus f3k. Then divergent f is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So now we are going to do the comparison of this, that is the components of vector f, f1, f2, f3. Comparison we are doing with this result. So this is f1, that is 3x square minus 3yz. This is f2, 3y square minus 3xz. The last one is 3z square minus 3xy. That is I, here j, here k. So the leftover f1, f2, f3. This is the divergent formula. So dou by dou x, f1 is substituted, plus dou by dou y, f2 is substituted, plus dou by dou z, f3 is substituted. So now here we have to do the partial differentiation with respect to x, we have to do it. So we will do with respect to f, 3x square, it's 6x. Here 3y square, it is 6y. That is y square differentiation is 2y. Put together 6y. And here 6z. We neglected these terms because here with respect to x, there is no x term at all. With respect to y, there is no y term. Here with respect to z, there is no z term. So 6x plus 6y plus 6z, we got it. 6 has been taken common. So 6 of x plus y plus z. Actually, this is our main question. We completed the problem. This is the question it is given, that is divergent f they told to find. Divergent f, the formula is this one. For that the basic, the vector f, this one. So our given question, vector f should be in this format, but it is not there. To bring that format, here the first gradient, that related formula, we applied it. We did according to that gradient what are the steps to be followed. We followed it here. We did, and we brought this format the question. That is the reason initially part of our problem we assumed as pi, then grade pi we did, and we brought the question to this format to make comfortable to reach the solution correctly, this divergent f vector. Now, the definition of solenoidal vector. A vector point function f is said to be solenoidal if divergent f equal to 0. Based on this, we will concentrate your problem. If the vector f, this is the equation, that is x plus 3y vector I plus y minus 2z, it is in the j vector, and x plus pz k vector is solenoidal. That means they told the given equation satisfies the condition of solenoidal. Find p. The solution is, first we know it the divergence of your vector. The divergence of your vector, the formula is vector f equal to f1i plus f2j plus f3k. Then divergent f, it is written dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. F is given, the given question, just we have written here. We want it to substitute in the formula of divergent f, dou f1 by dou x. So here x, the differentiation is 1. This is another variable, so we neglect it. This is f2. That is, we are comparing, this is our given question, f vector, the formula f1i plus f2j plus f3k. So this is playing the role of f1, this is f2, this is f3 according to this formula f1i plus f2j plus f3k. We are comparing and we did. So dou f2 by dou y. Here also y, the partial differentiation is 1. The next, dou f3 by dou z. Here the partial differentiation is p. X, y, this is treated. Other variables, in this 3y is another variable, here 2 is z, here x. They are treated as other variables according to the partial differentiation which we are taking. Here z we did, it is treated as neglected. Here y we did, it is neglected. Here x we did partially, 3y is neglected. Now this is the divergent f vector. This is the formula. What we got the results, we are going to substitute here. So dou f1 by dou x, it's nothing but 1. Dou f2 by dou y is 1. Dou f3 by dou z, the result is p. So the 2 plus p we are getting. If vector f is solenoidal, it is given, the given question, this vector f is solenoidal. Solenoidal in the sense the divergent f equal to 0, that is a condition of solenoidal. As our given vector, that is our problem, what is given, the vector is solenoidal. So that is the reason what we got it, 2p plus equal to 0 we are keeping. So p equal to minus 2. It is equated, this 2 plus p equal to 0. This 0 how we obtained here? Because of solenoidal. The next one is definition of curl of your vector. Now, the given vector f is continuous, differentiable, and vector point function. Then I cross dou f by dou x plus j cross dou f by dou y plus k cross dou f by dou z is called curl of f vector. That is, if curl of a vector cross product is playing the role, whereas divergence of a vector, just now what we discussed, dot product is playing the role. Now, the curl of f vector, it is written as curl f, or in symbol we can write it del cross f vector. This is actually gradient, grade cross f vector. Now, curl f vector, it's nothing but I cross dou f by dou x plus j cross dou f by dou y plus k cross dou f by dou z. Now, we will do a problem based on this curl of a vector. Find constants a, b and c if the vector, this is the given question, that is vector f equal to 2x plus 3y plus az of I plus bx plus 2y plus 3z of j plus 2x plus 3y plus 3z of k is irrotational. So the condition of irrotational, we must know it. That is, if curl f is equal to 0, then we will call it as irrotational. So we have to be very careful. Divergent f equal to 0, it is solenoidal. Curl f equal to 0, then it is irrotational. So the given question we wrote it, that is f vector equal to 2x plus 3y plus az of I. For j, bx plus 2y plus 3z. And the last one is, that is k vector 2x plus 3y of 3z. Curl f, we want it. Curl f, it is nothing but grade cross f. So, I, j, k, dou by dou x. So, under which it is written related to this I, the mutually perpendicular unit vector. So, here it is written f1. Here it is written f2. So, here dou by dou y. The last one is dou by dou z, for which the direction of k unit vector, that is 2x plus 3y 3z. This is f1, f2, f3. Now we have to do the determinant. So the determinant to find, first here I vector it is written. We will do these two cross. So here dou by dou y of this term partially with respect to dou y. This is neglected, this is neglected. They are other variables. We want only partially with respect to y. So the y is 1, 1 into c, c. The next, this we completed, minus, that is a rule of the determinant formula. This should be done with respect to z. So this, there are other variables neglected. Here 3z it is there. So we completed now dou by dou y of this, we got it c minus formula, and dou by dou z, these two are neglected, 3z. So here it should come 3, it's not z, 3. So this related to I we completed. So the determinant, this position is plus, here minus, this is plus. So according to that, here formula minus j vector this related to the product, this term and this term, and first that we will do it. There is this and this. With respect to x, we have to do it. Only this is considered. According to that, that is 2. The next, which we are concentrating this position, then particular column and row should be neglected. That is the determinant rule. The leftovers dou by dou z of this one. According to that, this is only considered with respect to z we are doing a. This is formula minus. Now the last one to be done, that is the cross product, this one. The k is written here. So now this we will do it. So with respect to x, that is b to be done. And this we have to see, that is here with respect to, we are doing y. So it is 3y, the partial it is 3. This is formula minus sign. So we completed here. The given question, the condition itself it is given, it is irrotational. So if the vector is irrotational, the irrotational to satisfy the condition is curl vector f equal to 0 vector. So what is the result? We got it. That should be equated to 0 because our given vector f is irrotational. If it is irrotational, the result should be equated to 0 vector. So the equating here, we got it. So c minus 3 equal to 0, we got it c equal to 3. And here minus 2 of minus a. So minus 2 plus a equal to 0, a equal to 2. So b minus 3 equal to 0, b equal to 3. So these are the constant values we got it. We will come to a conclusion of this video lecture regarding solenoidal and irrotational vectors. First, the definition of divergence of a vector. So compulsory the given vector should be continuous and differentiable of vector point function. So the formula is divergent f, it's nothing but grade dot f. So now one problem also we concentrated, that is f vector. We have taken one example. Finally, we did divergent f calculated. The final result also, the points are substituted as taking x, y, z. The values we substituted in the final, the point after doing divergent f. The next problem, it is not a direct question. The first one is the direct question, that is in the format of F1i, F2j, F3k, but it is not a different problem it is selected. So first we did grade and we brought the format of F1i plus F2j plus F3k and we solved it. And definition of solenoidal, that is this divergent f, if it is equal to 0, then it is satisfying the solenoidal vector. According to that, this problem it is selected. Using that p value, we got it. The next, we concentrated definition of curl of your vector. That is, here divergent is playing a role, whereas curl, cross product, it is playing a role. That is also we concentrated, that is a del cross f. For definition of irrotational vector, del cross f equal to 0. And we concentrated a problem that is given, it is irrotational. Using that curl f equal to 0, we found the constant values. Thank you very much.
Like, share, and subscribe. Hit the bell icon for more updates.